Okay, we're going to attempt to find the vertex given the equation in standard form. Um, we're used to finding it from factored form, but what we're going to do is find the vertex using standard form, and then we'll check ourselves with the factored form. So the first thing you want to do is make sure you identify all of your coefficients. So what I will do first is rewrite x squared minus 9x minus 36 as 1x squared minus 9x minus 36. All right. Now, if you recall, the way we get our vertex, our x coordinate of our vertex, is to take the opposite of the middle term. So that means since I have negative 9, I want to use the opposite of negative 9. And I want to divide that by 2 times the first term, the coefficient of the first term. So that'll be 2 times 1. Now, as I go to work this out, the opposite of negative 9 is equal to positive 9. And 2 times 1 is just going to be 2. And I can't reduce that, so that means that my x coordinate is going to be 9 over 2 for my vertex. Now, some students have a bias to decimals over fractions, so I'll keep that in mind. So some of y'all will probably say, oh, that's 4.5. So we'll use 4.5 as well. All right, so 4.5 is our x coordinate. So to get the second part of the vertex, what we're going to do is plug 4.5 back into our expression for the value of x. So that'll make it 4.5 squared minus 9 times 4.5 minus 36. And you can then calculate it, type it right into your calculator as such. And if you do, you'll find that that equals negative 56.25. So that's what we're saying our vertex should be. All right. So to check ourselves, what we're going to do is find the vertex using factored form. All right. So let me clear the screen. All right. So now, if you remember when we did factored form, we would have to make sure that our terms multiply to the constant term. So negative 12 times 3 is negative 36. And if I add negative 12 and positive 3, that will give me the negative 9 for the middle term. So that's factored form, x minus 12 times x plus 3. So to get our vertex, what we would do is we would have to find the midpoint. That means what I would do, the midpoint of my x-intercept. So what I would have to do is first take the opposites of each. So that means I have an x-intercept at positive 12 and then one at negative 3. And I would add those and then divide by 2. So if I go through 12 plus negative 3, well, that equals 9. So again, you're starting to see I'm left with 9 over 2, or if you prefer the decimal, 4.5 as the x coordinate of my vertex. All right. So then secondly, what I would do is go through, plug in 4.5 with the value of x. So it'll be 4.5 minus 12 times 4.5 plus 3. And I'm going to compute that. So this ends up being negative 7.5 this ends up being positive 7.5. And when I multiply those together, I'm still going to get negative 56.25, which shows that we had the correct vertex. All right. All right, so now that we know that that works, let's continue, look at another, and we'll also go ahead and formalize. Well, with this one, I actually have the factored form already, so I need to put it in put it in standard form so that I can calculate it using the standard form technique. So the first thing we needed to do is distribute so that we would have the standard form. So that means we would have 2x squared minus 10x minus 5x plus 25. And so if we go through and simplify this, that means we'll have 2x squared minus 15x plus 25. That's our standard form. All right. So remember, if we go through and try to get the vertex using that method, we want the opposite of the middle term. So that's going to be the opposite of negative 15. And it's going to be 2 times, over 2 times the first term. So over 2 times 2. So if I calculate that, that's going to be positive 15 over 4. And for our decimal lovers, that means our x coordinate is going to be 3.75. All right. And so again, whenever I want the second half of my vertex, I just need to plug in my x coordinate and evaluate it at that value. So I would do 2 times 3.75 squared minus 15 times 3.75 plus 25. All right. So if we go through and evaluate that, we will get negative 3.125. So if our standard form is 2x squared minus 15x plus 25, its vertex should occur at 3.75, negative 3.125. All right. So again, let's check real quick because we have the factor form. So remember, the first thing we had to do was find our x-intercepts. To get this x-intercept, since I can't just change the sign, I'll set each factor equal to 0. Alright? That'll give me the x-intercepts. So I work through this one, I would get x equals 5. If I do this one, I'd have 2x equals 5, and then have to divide by 2. So x will be 5 over 2, or 2.5. Alright? So when I go through and add those two together, so if I decided to do 5.5 over 2 plus 5 and divide that over 2, that's going to give me, let's say if we do it this way, 5 over 2 plus 10 over 2 it's going to be 15 over 2 over 2, which will turn into 15 over 4. Now that should look familiar because remember, as a decimal, that's going to become 3.75, which is again our same vertex. Okay? But to finish things out, we can now plug that value in to our factored form. So we would have 2 times 3.75 minus 5, and then 3.75 minus 5 in the second binomial. And then we can just go through and compute. So in this one we would get 2.5. In the second one we get a negative 1.25. And then if we multiply those together, again we'll get a negative 3.125. So we can see again that our vertex formula for standard works. All right. Okay. Let's take a look at one last one. So remember, first thing we have to do is get this in standard form. That means we'll end up with, this is going to be 5x squared plus 15x minus 6x minus 18. We clean things up, combine like terms. We'll get 5x squared plus 9x minus 18. So that is our standard form. 5x squared plus 9x minus 18. Alright, so remember, what we need is the opposite of the middle coefficient. So that means we're going to have negative, or the opposite of 9, over, and it's always over 2 times the first coefficient, or the leading coefficient. So that'll be over 2 times 5. Alright? So that means we'll end up with negative 9 over 10. And again, decimal levels. That's going to be negative 0.9. So we're saying that that's where our vertex is going to occur on the x-axis. Alright, so now, just as before, we're going to plug that value in and see if we can get our y-coordinate. So that'll be 5 times negative 0.9 squared plus 9 times negative 0.9 minus 18. Alright? Alright, and we calculate that, put it in the calculator for a little help. We will get negative 22.05. Alright, so again, we're going to check, make sure we did it right, because we'll check with the factored form method. Alright, so again, I need my x-intercepts first. So that means I'll set that 5x minus 6 equals to 0, and I'll set x plus 3 equals to 0. That means one of my intercepts is going to be a negative 3. If I work this one, 5x will equal 6, divide both sides by 5. That means this will become 6 over 5, or 1.2. Okay? So remember, now that I have my intercepts, I need to add them and then divide by 2. Well, 1.2 plus a negative 3 is going to be a negative 1.8 if we just deal strictly with the decimals. And once we divide that by 2, we got negative 0.9. So again, things are already looking to match. The final step, we just plug that negative 0.9 in. So that'll be 5 times negative 0.9 minus 6 times negative 0.9 plus 3. And That means this will equal that'll be 2.1. We go to this one. We'll get negative 10.5. And then when we do that final multiplication, again we get negative 22.05. So, to wrap things up, remember, when you're looking for your vertex from standard form, remember standard form looks like this: ax squared plus bx plus c. We want to take the opposite of our middle coefficient, divide it by 2 times the leading coefficient, and that gives you the x coordinate. After that, you plug that value into your expression for x, and then you'll get the second half, the y coordinate.